All right, so we're going to continue 4-3. Remember, the goal of 4-3 was to see how the values of a, h, and k affected a quadratic function, a quadratic equation. So we had already talked about what h and k do, the translations, moving left, right, up, and down. But now we're going to see what a does to a quadratic, and that deals with the stretches, compressing, and reflecting part, okay? So if we look at the stretching to start, so we're going to start with stretching a quadratic function, okay? If the absolute value of a, okay, remember a is that number that's attached to the x squared. If the absolute value of a is greater than 1, then the graph of ax squared is narrower than the graph of the parent function x squared. Narrow. What's another word for narrow? A little louder? Skinny. Yes. Okay. So if there's a value, if a is bigger than 1, I'm talking about the absolute value of a is bigger than 1, then it makes the graph skinnier. We've kind of seen this already when we started graphing quadratics, okay? But the original parent graph of x squared, okay? I'm just going to rewrite the table from last time. You don't have to write this. Remember, this is the original table from the green foldable, okay? These values are going to be affected if there's an a. Which one of these values is going to be your y values, okay? So all of these original y values are going to be affected by your a. We're not going to add and subtract the value because that deals with the translating, moving it up and down. But what we're going to do is we're actually going to multiply our y's by a, okay? If there's an a value, that you multiply your y's by that value, all right? So my x's, they don't change, okay? All of my x's stay the same. But these y's, the original y's of x squared, they're going to be multiplied by what number? 2. So I'm going to multiply all of my y's by 2 to get the new y's of this 2x squared quadratic function, okay? 9 times 2, 4 times 2. 1 times 2, 0 times 2. A little bit more. 1 times 2, 2. 4 times 2, 8. And then 9 times 2, 18. We're multiplying all of the original y values by 2. This is going to cause the original quadratic function of x squared to be stretched by 2. That's how you would describe it, okay? So go ahead and plot these points on your graph. Go ahead and plot these points on your graph. Yeah, it's not going to be 18, so you're only going to be able to go up to the 8. Now remember what I said the other day about the translating, okay? If I ask you to graph, you can graph however you choose to graph. If you like to make your own table of values and plug them into the function, that's fine. If you like the pattern, 1, 3, 5, you can do that. But if you're given a table and you're given a function, they're asking you to complete the table, you need to know how to do that. Or if I ask you to describe what's happening to the original function, you have to tell me that it's stretched by 2. Does everybody understand that? All right. And just to show you, just real quick, in case you can't see it, these points here I'm putting that are like kind of tannish colored, that represents the original x squared function. So as you can see, it's getting skinnier. if A, the absolute value of A is greater than 1. Questions? Okay. That's stretching. Compressing is when the absolute value of A is less than 1. If it's less than 1, and I'll even do this as well. I want you guys to write this in there. Make it so that it's A is greater than 0 but less than 1. Add that in there. Okay? Add that in there. So the absolute value of A is in between 0 and 1. Then the graph of AX squared is getting wider than the graph of the parent function X squared. It's getting wider. It's getting bigger. Okay? Because think about it. If you take like, say you take like some Play-Doh and you put your hand on it and you start to bring your hands together, right? The Play-Doh is going to end up spreading out, right? Compressing. So it's going to get wider. All right? So those original points on X squared, okay? Again, the Y's are getting affected. A affects your Y values, okay? So if I have Y equals 1/2 X squared, I'm going to multiply all my Y values by what? 1/2. So I'm going to multiply them all by 1/2. Does anything happen to my X's? No. So all of my X's stay the same. But all of my Y's are going to get multiplied by 1/2. What's 9 times 0.5? Or what's half of 9? 4.5. 4 times 1/2. What's half of 4? 2. What's half of 1? 1/2. What's half of 0? Nothing. 0. And then it repeats. Okay, half of 1 is 0.5. Half of 4 is 2. Half of 9 is 4.5. And remember, these give you the points that you can use to graph your quadratic. Okay? So go ahead and everybody plot these points. Everybody should plot these points now. And even though I know it's not a part of your basic table, let's add in one more point, okay? On the original parent graph, if I plug in 4 in for X, what's 4 squared, bless you? 16. So if I wanted to add one more, what's half of 16? 8. So at 4, we'll be at 8. I just wanted to add that one in. And I just reflected it over the axis of symmetry. Just wanted to add that one in so you guys can see that with the original graph, how it's getting wider. Does everybody see that? So the tan represents the original function, x squared, and then the blue represents the 1/2 x squared. And you would describe this by saying it's being compressed by 1/2. That's how you would describe it. So the value of A affects your Y's. You multiply your Y values by A. Okay? Now, the last of the transformations that we're going to talk about with quadratics is reflecting. Okay? This is where it kind of gets a little bit sticky because this is when you're looking at A when it's less than 0. Okay? In other words, a negative. Okay? If there is a negative involved, then that means that the graph of ax squared is a reflection across the x-axis of the original parent function. Okay? So anytime you see a negative, you know that it's going to be a reflection across your x-axis, or a reflection over x-axis. Anytime you see a negative, it's going to be a reflection over your x-axis. That's how you would describe that transformation. Okay? And just like before, all of your y values are going to get multiplied by a. All of your y values are going to get multiplied by a. So those original values, I'm just rewriting them to serve as a guide. All those y values are going to get multiplied by what? Which was a? -1, okay? So you're going to multiply all of these by -1. Do your x's change? No, they don't. So all of those x's stay the same, but all of your y's, what's the first y value going to be? Keep going. Keep going. Keep going. You plot those points and you graph it, and it will show how the parent function was basically reflected over the x-axis. So let's talk about this, okay? Again, if I ask you just to graph a quadratic, you choose the means in which you want to graph it, okay? If you want to do all the transformations like how we've been doing the last 2 days, then that's fine. If you want to find the vertex and do the pattern, that's fine too. If you just want to plug in random x values into the function, work it out to get the y values, that's fine too. Graphing, you can do it however you like. But if it's asked, how do you, or what happens to the original x squared function, then you actually have to say it's a reflection over the x-axis. It moves to the right 5 units or whatever. If a table is given to you and they're asking you to complete a table, then you have to know how to do that. A affects what? Your x's or your y's? And what do you do with A and your y's? You multiply them. Going back over the lesson from Wednesday, H. Does H affect your x's or your y's? Your x's. And what do you do with those? What do you do with H and your x's? Add or subtract. What about K? It affects your y's. And what do you do with K and your y's? You add or subtract, okay? So, we're going to practice a little bit. All right? What I want you guys to do is go ahead and grab a marker and a felt, and we're going to practice a few problems incorporating everything together. Okay? Incorporating everything together. Okay. So, everybody has a marker on your desk. I'm going to give you a quadratic. Okay? I want you to first describe the different types of transformation. Is it a compressed? Is it a stretched? Is it reflection? Is it moving left, right, up, or down? And then, of course, associate the numbers with it. After that, I'm going to want you to complete the table. Okay? I'm going to want you to complete the table. I'll try to start you off a little easy. Okay? So, we did this yesterday just to refresh your memory. On the inside, Remember, this was example moving left. This was example moving down. This is what we did the other day. I want you guys to try this one, okay? This is an equal sign here. You're describing the transformations, and then you're going to complete the table. If you have questions, please ask. What did I say? Actually, that's... Well, yeah, it would be for that particular value. Yeah. You should reflect first. All right, so let's talk about the descriptions, okay? What is happening to the original x squared function? What's happening to this original function to get this? There's three transformations. Okay, I heard two things. I heard it's a reflection. A reflection over what? X-axis. Please make sure you put x-axis, because there is a reflection over the y-axis. Okay? So a reflection over x-axis, and then what you say? Then it's moving to the right 1 unit. Okay, remember when it's on the inside, you have to think what is h, what you plug in. And then there's the last one. What's the last one? Up 3 units. So if I ask you to describe it, that's what you would put, okay? Make sure you don't forget any transformations. Now you have to complete the table. Remember, what affects your x's? Which letter affects your x's? H. What is h here? Actually, h is a positive 1. So then we're going to have to add 1 to all of our x's. We're going to add 1 to all of our x's. But there's 2 things happening to our y's. It's getting reflected and it's moving up. Remember, reflections is A. We multiply our y's by A. And then we either add or subtract our k's. Order of operations, which one do you do first? You do your multiplications first. So you're going to need to multiply by your A value first and then add your K. What's my A value? My A value is -1. And then my K value is 3. So I have to take all of my Y values, multiply them by -1, and then add them by 3. Because you do your multiplications before you do your additions or subtractions. Okay? So I'm going to add 1 to all my X values. That's -1, 0. Awesome. And now I'm going to multiply my y's by -1 and then add 3. What's 4 times -1? Plus 3. What's up? Okay, I'm about to do it as soon as I finish. What's 1 times -1? Plus 3. 2. What's 0 times -1? Plus 3. I'm taking these y values right here and doing all of those things to it. What's 1 times -1? Plus 2. And what's 4 times -1? Plus 3. And that's the table. These will be the points that you could plot to get your graph. Okay? Clear your desk. Let's try another one. Don't worry about the graph. I just want you to describe and complete the table. Describe and complete the table. No. Remember, this process of completing the table is you're taking these values and you're adjusting them based off of the different transformations. So we're not plugging in anything into anywhere. Okay? We're just affecting these coordinates with the different types of transformations. Okay? Let's describe. How many transformations are there? 2. What are they? So reflection over the x-axis and right 5. Make sure you put x-axis. So what am I going to do to my x's? Add 5. And what I'm going to do to the y's? Multiply by -1. So I'm going to add 5 to all of these x values that are given to me. So that's going to be Awesome. And then to my y's. Awesome. And then, of course, you can use those to graph. Okay? But I'm more concerned about those two things. Okay? Clear your desk. Let's step it up a notch. Okay? Let's step it up a notch. Let's look at this one. Let's look at this one. Now, because if you think about a reflection over your y-axis with a quadratic, it's the exact same thing. And then, like, to try to distinguish between the two, it's rare. It's going to be written in the way that it needs to be written. All right, so for this one, 4 transformations. What's one of them? Reflection over the x-axis. That negative indicates that there's a reflection over the x-axis. And the 3 represents a stretch, a 3-unit stretch. So whenever there's an a value in front, if it's negative, that lets you know that it's a reflection. And then the value itself is either the compression or the stretching. Stretching if it's bigger than 1, compressing if it's in between 0 and 1, the absolute value is in between. What about the inside? Left 6. And then the 1 means up 1 unit. Yes. Okay. 4 transformations for this one. What am I going to do to my x's? Subtract 6. And that's it. But to my y's, I'm going to multiply by -3 and add 1. You multiply by a, you add or subtract your k. So my x's are going to turn to -8, -7. And then my y's, I'm going to multiply by -3, add 1. So 4 times -3 plus 1. 1 times -3 plus 1. 0 times -3 plus 1. And then the 1 and the 4 are going to be the exact same values from before because it's symmetric. And then you use those to graph. How do you feel? Okay? All right.